Okay, in adding these fractions, if we recognize 7 as a common factor, I could write this as 18 over 7 times 11 and 15 over 7 times 4, right? Now, if I want the same denominator, what do? Well, I take my 18 over 7 times 11, and I want this denominator to have everything in it that's in the other denominator as well. Is there anything in this denominator that isn't in this one? What's in this denominator that you don't see in this one?
4.
The 4, right? So I multiply this by 4 over 4. And now my denominator will be 7 times 11 times 4, right? And then to that I add, well, I've got to add 15 over 7 times 4. Is there anything in this denominator that isn't in this one?
77.
Oh yeah, the 11. So I multiply by 11 over 11. Okay? Make sense? And I'm just going to say etc. because at this point you have the same denominator, right? Now you can just do as we did up here. So it's just an exercise in getting everything in terms of the same denominator, okay? Now more generally, I'm going to do this by factoring everything as much as it can be factored, okay? So if we do it again, 18 over 77 plus 15 over 28. Every number I'm going to factor, okay, into primes. Prime factorization, something you should know, but if it's been a while, if you didn't really get it when you got it and got it long enough to pass the SOL and forgot it, okay? So let's see how we do this. Okay, we do 18. Now what's the smallest prime number? 2. Okay? Does 2 go into 18? Good. How many times?
9.
You can do this arithmetic. Yeah, you know. Okay, so we get 2 and we get 9. Okay? And then, well, we can't factor 2 anymore because it's a prime, right? How about 9? What's the smallest prime that'll divide 9?
3.
Yeah, 2 won't divide it, so we go to 3, and well, bingo, we got it, okay? So we got 2, and we got 3, and we got 3. Similarly, 15 breaks down to 3 times 5. And 77 breaks down to 7 times 11. And 28, okay, what's that break down to? First step. Start with the smallest prime. Smallest prime is 2. Will it divide 28? Yeah. So you get 2 and 14. Now 2's prime, so it's not going to change. What's the smallest prime that divides 14? 2. We get 2 times 7. Okay? So now we're going to rewrite everything. We're going to write this as, that's 15, 2 times 3 times 3 over 7 times 11 plus 3 times 5 over 2 times 2 times 7. Now, you know, you're told to write 2 times 2 times 7 is 2 squared times 7. But for the purposes of what we're doing here and for comparison, I'm going to write out every factor. Now, if you get down to something that factors down to 2 to the 47th power times 19 to the 34th power, go ahead and write exponents and figure out what to do. But you've been taught that. Okay? So now, what do? Well, we write everything as before. We still just look at the denominator. Okay. What's this denominator have that this one doesn't? Huh? Yeah, 2 times 2, right? So we have to multiply this by 2 times 2 over 2 times 2. Okay? And over here, we got this much. What does this have that this one doesn't? The 11, right? So multiply that by 11 over 11. Okay? Which gives us 2 times 3 times 3 times 2 times 2 plus 3 times 5 times 11. And we could factor out 1 over the denominator, but you see how that works. So that's going to be 7 times 11 times 2 times 2. And both denominators are that. So we have it. Now we could multiply all these numbers out, but there's really no point in multiplying the denominator out, because if we do, we're going to have to figure out what its factors are to see if anything divides into the numerator. But we already see the numbers that might divide in the numerator and divide out, right? Now, maybe you understand that, maybe not, but let's see what we get. That's 8 and that's 9, so this is 72. That's 15 times 11, which is 15 times 11, 165, over 7 times 11 times 2 times 2. Now, why didn't I multiply this out? Well, you see in a minute. Why did I multiply these out? Well, because if I add these up, I get 237 over 7 times 11 times 2 times 2, right? Now you can check my arithmetic. That's easy enough. And maybe I made a mistake, so do check my arithmetic. But now let's factor this 237. Okay? Will 2 go into 237? Well, obviously not, right? Will 3 go into 237? You should not need your calculator to do this. First place, there's a rule: add up the digits. If they're divisible by 3, it's divisible by 3. But 240 is divisible by 3 because 24 is divisible by 3, right? And if you don't have that much arithmetic, put your calculator away for about 10 years, okay? Well, if 240 is divisible by 3, this is only 3 less, so this has got to be divisible by 3, right? So this is, well, let's do 237. That's 3 times 79, okay? Because 3 times 80 is 240, right? And if you can't do that in your head, you're not doing enough mental arithmetic. Either that, you could have a disability. Mostly it's just too much use of the calculator. And you need to work on that. Put it away unless you really need it, until you really need it. And push yourself a little bit on mental arithmetic. There are things you can't think well about unless you do a little bit of mental arithmetic. You've always got to reach for the calculator. You keep interrupting your thought process. Okay, well, anyhow, 79. Well, 79 isn't divisible by 2, is it? It's divisible by 3? Nah. 5? Nah. 7? Well, it goes into 77, but not 79, right? 11? Well, if 11 goes into 79, it goes into it less than 7 times. Which means that one of the numbers you divided by would have already divided it, so you can stop. In other words, you only go up to the square root of the number, and the square root of this is a little less than 9, right? Because 9 squared is 81. Okay? So now we know that this is 3 times 79 over 7 times 11 times 2 times 2. Okay? Now, we know that this thing doesn't reduce because none of these numbers match any of these numbers. Okay? There's no match. So this doesn't reduce. So now we can multiply these numbers out. we got 237 over what? 77 times 4 is 280 and 208, 308, or 28, 308. Now, if I'd have multiplied all these numbers out here without doing this, what would I had to do to verify that this doesn't reduce? I'd have to factor these and see if any of the factors work. Okay? That's why I didn't factor, that's why I didn't multiply out the denominator. I can see what the denominator number is, and I can see what the numerator is in terms of primes, so I can tell whether they reduce or not, and how to reduce them. Okay? Now, by analogy, we need to do this with polynomials.